Welcome to CE 402 Environmental Engineering 2 Module 5 Part 3. In this session, I am going to discuss about the IMHOF tanks, which is an improved version of septic tank in which incoming sewage is not allowed to mix up with the fresh sewage, or the incoming fresh sewage is not allowed to mix up with the sludge produced in the septic tank, and the outgoing effluent is not allowed to carry with its large amount of organic solids as in the case of septic tank. This is constructed as two-storied digestion tank and a sedimentation tank. This is designed by German scientist Karl Imhoff. This is also known as two-story digestion tanks. In the upper compartment, sedimentation happens, and in the lower compartment, the digestion process happens. The upper chamber of the tank remains filled with the sewage, and the compartments are connected by opening in the partition between them. Then the construction and operational features of a Imhoff tank. It is double chamber tank. The upper chamber is called sedimentation or flowing through chamber, through which the sewage flows at a very low velocity, and the lower chamber is the digestion chamber, in which anaerobic or septic conditions or decomposition occurs. The solids of the sewage settling to the bottom of the sedimentation chamber through the sloping bottom walls, that is slope 5 to 4, 5 vertical to 4 horizontal, are made to fall in the digestion chamber through an entrance slot at the lowest point of the sedimentation chamber. The slot with a minimum width of 15 centimeter slot is trapped or overlapped in such a way that the gases generated in the digestion chamber cannot enter in the sedimentation chamber, and thus avoiding the direct contact of sewage with any type of foul gases and its consequent pollution. A gas vent, also called a scum chamber, is provided with the digestion chamber to take care of the gases escaping to the surface. The chief gas is methane, so we can collect this methane gas and we can use it. In order to prevent the particles of sludge or scum from the penetrating into the sedimentation chamber, the sludge and scum must be maintained at a distance of about at least 45 centimeter below and above the slots respectively. That is, the slot is provided at the sedimentation chamber and a slot is provided at the top of the digestion chamber also. This free or clear zone is called neutral zone. That is, a clear zone will be provided in order to prevent the entrance of scum layer into the sedimentation chamber. This is known as neutral zone. The digestion chamber is made up of 2 or 3 inverted cones called hoppers with a side slope of 1:1, so as to concentrate the sludge at the bottom of the hopper. The sludge is removed periodically by using sludging arrangements, that is desludging arrangement, that is desludging pipes provided in each compartment. The sludge is removed with the flow under the hydrostatic pressure of 1.2 to 1.8 meter. All the sludge is not removed, only the lower layers which are completely decomposed are withdrawn, leaving some sludge to keep the tank seeded with the anaerobic bacteria. To permit a uniform distribution of settled solids throughout the length of the digestion chamber, so as to utilize the storage capacity in the greatest measure, arrangements for reversing the direction of flow through the tanks are commonly made. This is the plan view. First picture is the plan view of an Imhoff tank. Here you can see a common common sedimentation tank is provided, and at the bottom part you can see the digestion chamber with sloped bottom side, that is marked as dotted lines, and you can see the total length of the sedimentation tank you can find out, and the total depth of this Imhoff tank has to be found out during the design. And here the section is given in the in the third figure, that is the figure C, that is BB section, that is the section of an tank itself, single chamber. Here you can see the gas vent, and the first cone inside this bigger cone is the sedimentation chamber, and you can see the slot arrangement at the bottom of this sedimentation chamber in order to enter the settled sediments or sludge into the digestion chamber. The bottommost bigger cone is the digestion chamber, and this in this chamber the digestion happens, and here you can see the total width of this digestion chamber is 6.5 meter, and you can see the slope is 1:1 in the digestion chamber, and in the sedimentation chamber the slope is 1:1.25, and the width of the sedimentation sedimentation chamber is 4.5 meter, and you can see the gas vents are provided by the sides of the digestion chamber. The total width is 6.5. So after deducting this 4.5 meter, you will get the length of the gas vent on both sides of the digestion chamber. And you can find the neutral zone here at the middle of the total depth, that is uh, in order to resist the entrance of scum layer into the sedimentation chamber, 0.45 neutral zone is provided, and the total cone depth is 2.1 centimeter, and you can see the total rectangular portion depth is 3.13 meter, and you can see the conical portion in the sedimentation chamber as 2.81 meter depth, and the rectangular portion depth in the sedimentation chamber is 0.7 and a freeboard of 0.45. The total depth can be calculated by adding up the depth of the neutral zone plus the total depth, that is the depth of the sedimentation chamber plus the depth of the digestion chamber. Here in the figure B, that is section AA. Section AA means lengthwise section. Here you can see four numbers of these digestion chambers connected with the sedimentation chambers, and the sediments from this sedimentation chamber enter into these digestion chambers, and digested sludge can be collected using these desludging pipes, and the inlet is provided, and you can see the outlet also, and this is the main sectional view and plan of an Imhoff tank. Then the design criteria, that is design considerations. Here the retention period is 2 hours, and a flow through period, that is flow through velocity is 30 centimeter per minute, that is 0.3 meter per minute, and a surface loading of 30,000 liters per meter square per day. Length should be preferably not exceed 30 meters so as to provide good sludge distribution. And the length to width ratio between 3.1 to 3:1 to 5:1. The depth should be, as far as possible, be kept shallow to permit particle falling to the slot before reaching the end of the sedimentation tank. In practice, the total depth of the tank between 9 to 10.5 meter is considered sufficient. Greater depth involves difficulty of excavation, that is, desludging will be very difficult. And the freeboard provided may be 0.45 meter or 45 centimeter. Then the second portion is the digestion chamber, and third is the gas vent or scum chamber. The design of an Imhoff tank consists of the design of sedimentation chamber and design of digestion chamber and design of gas vent or scum chamber. In the design of digestion chamber, the surface area of the digestion chamber at 0.028 to 0.056 meter cube per capita is considered sufficient in warmer climates where shorter periods between sludge withdrawal are possible. Then the second criteria is the surface area of the scum chamber should be 25 to 30 percentage area of the horizontal projection of the top of the digestion chamber. That is the digestion chamber's surface area. That is the scum chamber should be 25 to 30 percentage area, total surface area of the digestion chamber. And the gas vent or scum chamber, the surface area of the scum chamber should be about 25 to 30 percentage of area of the horizontal projection. Then advantages of Imhoff tanks. They are quite economical in operation. They do not require skilled attention during the operation. There are no moving parts. They require only preliminary treatment. There is no difficulty in sludge removal. Desludging process is easy. Also, the sludge volume and the weight are less. The results obtained are good with 60 to 70 percentage removal of solids and 30 to 40 percentage removal of BOD happens in an Imhoff tank. Then disadvantages of Imhoff tanks: because of the greater depth, cost of construction is higher, especially where excavation is to be done in quicksands or solid rock, they become uneconomical. Unsuitable where the high acidic conditions exist because of the character of the sewage involves. Then they give offensive orders when improperly operated. No adequate control over their operation. This makes them unsuitable for use in large treatment plants where separate sludge digestion tanks are preferred. They have a tendency to form or boil, due to which the sludge particles may enter the sedimentation zone through the slot, thus affecting the quality of the effluent. Then the troubles in Imhoff tank. The main trouble in Imhoff tanks are foaming. That is, foaming is the main trouble caused during the operation of Imhoff tank. It can be caused by insufficient capacity of the digestion chamber. That is, if the digestion chamber having an insufficient capacity and we are loading a large quantity of sewage into this, then the digestion chamber will be overloaded and this digestion layer, that is the sludge layer, will be thicker, that we already more than that of that designed value. Then it will create problems like foaming. Then violent biological action giving rise to large volume of gases. That is, if the anaerobic conditions exist, the anaerobic bacteria decompose the sludge deposited at the bottom of the digestion tank, then there will be a chance of a triggerous action, that is an acceleration in the decomposition action inside the digestion tank. Then the gases produced will be of larger quantity. Then there will be chances of forming inside the digestion tank. Then fermentation caused by highly acidic influence. If the condition is acidic, fermentation can happen. and it will also cause foaming in the digestion tank. Entry of large quantity of soap water. If the wastewater contains large quantity of soap water, then also the foaming will happen. Then foaming can be controlled by correcting the acidity by adding a hydrated lime, withdrawing sludge more frequently, and increasing capacity of the digestion chamber, and proper seeding. That is, bacterial colony should be maintained inside the digestion chamber and allowing the tank to rest for few days in order to complete the digestion process inside the digestion chamber. These are the main design part of Imhoff tank, that is design of sedimentation chamber, design of gas vent and neutral zone, then the design of digestion chamber. I hope you all understood the session. Thank you for listening. See you in the next class.